oscillating mass attached to a spring using the momentum principle and energy principle. So to do this, we will use observations to create a model based on Newton's second law and predict the motion observed. We will plot observations with the predictions. And the result is that the momentum and energy principle will allow us to predict the motion of oscillating mass on a spring. This follows the energy principle in that the sum of all energies is equal to 0. I have the initial position shown here, and this is from the tracker data. And I started measuring my data just after Dr. Greco released the ball. So velocity starts at 0, which is shown here. And from this, I calculated the momentum. Delta T was given as 1 over 210, and the video lasts 9.212 seconds. I calculated the spring constant using K sub s equals 4 pi squared times the mass divided by time squared, and then I calculated L naught, the relaxed length of the spring, using the principle that the vector F grav equals the vector F spring. So I used the formula L naught equals the L vector minus mass times gravity, or mass times g divided by k. This is a screenshot of all my tracker data, and here you can see the positions, and this is a graph of all the data. So when I run my model, you can see the mass oscillating vertically on the spring and the mass swinging in an arc. And here you can see a graph of the motion and energies. And here are some more important features of the code. So I found F grav using the mass of the ball times gravity, and I saw for L, which is the ball position minus the spring position, and I found F net, which is F grav plus F spring, and then the ball velocity, and then the final position. And here is also how I found F spring in this line of code. And then lastly, I found the energy changes. So I found delta K, delta gravitational potential energy, and delta gravitational, or delta spring potential energy. This is delta spring potential energy. So the model matches well with that which was tracked in the video. The blue ball showed the model data and the red ball showed the tracker data. And the yellow line is the sum of the energy, the red line is the change in energy, the blue line is the change in kinetic energy, and the green line is the change in potential energy. For the what does it mean question, I was asked to compare the period of oscillations for the x position data and the y position data. For the y position, the period was 1.49. For the x position, the period was 1.57. These values are different because they are independent of each other. The forces are different because F grav is affecting the y position. For what does it mean question 2, I was asked, for my model system, is the energy principle satisfied? Work is 0, which you can observe from the graph that is printed from the computational model. And yes, this satisfies the energy principle, which states that delta E equals W. Because work is 0, delta E must be equal to 0, and from the model, we can see that it is.